Measures of positions for ungrouped data. When a set of data is arranged from lowest to highest, the distribution can be divided into 2, 4, 10, or 100 equal parts. The measures of positions that divide a distribution into 4, 10, and 100 equal parts are known as quantiles. So if we have 4 equal parts, this will be quartiles. 10 equal parts, we have deciles. And 100 equal parts, we have percentiles. These descriptive measures, namely quartiles, deciles, and percentiles, can also be known as fractiles. Ungrouped data. These are also the raw data, which means they have just been collected but not sorted into any group or classes. The quartiles are the score points which divide a distribution into 4 equal parts. There are 3 quartiles denoted by Q sub 1, Q sub 2, and Q sub 3, which are the first, second, and third quartiles respectively. Our Q sub 1 is also known as lower quartile. Q sub 2 is also called as middle quartile, and Q sub 3 is also the upper quartile. 25% of the distribution fall below the first quartile, 50% falls below the second quartile, and the 75% falls below the third quartile. So using this illustration, we have the smallest value going to our largest value. This graphical representation shows that 25% or 1/4 of the data will be less than or equal to our Q sub 1. And at least 75% will be greater than it. Our Q sub 2 or the middle quartile is already the median of the data. And at least 75% of the data will be less than or equal to our Q sub 3 or the upper quartile, and 25% is greater than it. In quartiles, we have the difference between the third quartile and the first quartile, or that is Q sub 3 minus Q sub 1, and this is called as interquartile range. Quartiles for ungrouped data. Let's have an example. A group of students obtained the following scores in their math quiz: 8, 2, 5, 4, 8, 5, 7, 1, 3, 6, and 9. The first step is arrange the scores in ascending order. So we have 1 as the smallest value and 9 as the largest value. So with these numbers, we have a total of 11 numbers. So it refers to our n. Now, to find for our middle quartile, or the Q sub 2, our second quartile will be 5. This is obtained by observing the position of 5, which is in the middle of the numbers from 1 to 9. And then, our first quartile, or Q sub 1, will be 3. So by the way, the middle quartile is also known as median. Now, the first quartile is 3. This is obtained by observing the position of 3, which is in the middle of the number from 1 to 5. So this is known as the lower quartile, or the Q sub 1. And our third quartile will be the first 8. This is obtained by observing the position of 8, which is in the middle of the numbers from 6 to 9. So this is called as upper quartile or the Q sub 3. Now, in finding the quartiles for ungrouped data, using statistics for engineering and the sciences, define a different method of finding quartile values, and this is called as Mendenhall and Sinsich method. Let's have an example. Consider the set of scores in a quiz in Math 10. We have already arranged data. We have 9, 10, 10, 12, 15, 16, 16, 18, and 19. Now, to find the Q sub 1, we locate its position using the formula Q sub k is equal to k over 4 times n plus 1 and round off to the nearest integer. Now, we use Q sub k because we are pertaining to the quartiles. Our k refers to 1, 2, or 3 because there are 3 quartiles. And we have over 4, it's because we have the quartiles which divide the data into 4 equal parts. Again, our n will be the total numbers here. So since 9 is the smallest value, 19 will be the largest value. So as we substitute the position of Q sub 1, so our k here is 1 because we are finding the lower quartile or the Q sub 1 equals k is equal to 1 again over 4 times we have a total of 9 scores, so n is 9 plus 1. Simplifying this, 9 plus 1 is 10 and 1/4 of 10 is equal to 2.5. Why does it become third data? The rule in finding the Q sub 1 using Mendenhall and Sinsich method, we have to round up. So from 2.5, we'll get 3, or the third data from the given array or arranged data, that would be the second 10. So therefore, our lower quartile or the Q sub 1 value is equal to 10. How about if we're going to find for the Q sub 3 or the upper quartile? So to find this, we locate its position using the formula again of Q sub k is equal to k over 4 times n plus 1. And then we round off to the nearest integer. Thus, we have the position of Q sub 3. Our k here is 3 because we're looking for the upper quartile. So your k becomes 3 over 4. Our n again is 9. 9 plus 1 is 10. And 3 over 4 times 10 will be equal to 7.5. And the rule here in finding the Q sub 3 value for the quartiles for ungrouped data, we need to round down. So we have 7.5 rounding down, we have the 7th data. Now the 7th data among the arranged data here will be 16. So our Q sub 3 or the upper quartile value will be 16. Another method in finding the quartiles for ungrouped data is what we call linear interpolation. Let's have example. Consider the set of scores in a quiz in Math 10. We have again arranged data 11, 13, 14, 15, 15, 16, 19, 20, and 20. So from this given example, we have a total of 9 scores. So the first step is we arrange the data. So since it was already arranged in ascending order, let us now find our Q sub 1. We locate the position of the score in the distribution. So again, we use the Q sub k is equal to k over 4 times the quantity of n plus 1. Thus, by substitution, we are looking for the first quartile. So our k is equal to 1. So 1/4 times our n again is 9. 9 plus 1 is 10. And 1/4 of 10 is 2.5. But this time, we're not going to round up or round down. So since the result here is a decimal number interpolation now is needed. So for the linear interpolation, the first thing we have to do is subtract the second data from the third data. So why is it second and third data? We obtained 2.5 a while ago in the position of q sub 1. So our 2.5 is between the second and the third data. So among these numbers in arranged data, our second and third data will be 13 and 14. So subtracting these two numbers, we have 14 minus 13 is equal to 1. Multiply the result by the decimal part obtained in the position of q sub 1. A while ago, we obtained 2.5. The decimal part of that is 0.5. So the result in number 1 here is 1. And then we multiply 1 by the result a while ago in position of q sub 1, which is 0.5. So we have 1 times 0.5 is equal to 0.5. Add this result to the second or smaller number. So between 13 and 14, the smaller one is 13. And since we used the second and the third data, we'll be referring to the second data. So add the result, we obtained 0.5, we'll add this to the second or the smaller number, which is 13. So we have 0.5 plus 13 is equal to 13.5. Therefore, using linear interpolation, our q sub 1 value is now equal to 13.5. The same thing if we're looking for our q sub 3 or the upper quartile. So make it sure that our data are arranged in ascending order, and then we locate the position using the formula of q sub k is equal to k over 4 times n plus 1. Thus, since we are looking for the third quartile, our k is 3. By substitution, we have 3 over 4 times the quantity of 9 plus 1. 9 plus 1 is equal to 10, and 3/4 of 10 will be equal to 7.5. So since we obtained 7.5, we'll be using the 7th and the 8th data in this given arranged data. So following the steps of linear interpolation, we subtract the 7th data from the 8th data. So from this given array, the 7th and 8th data are 19 and 20 respectively. So we have 20 minus 19 is equal to 1. This result 1 will be multiplied by the decimal part obtained in the position of q sub 3. Since we have solved a while ago 7.5, its decimal part is 0.5. So we have 1 plus 0.5 is again equal to 0.5. And then add this result to the 7 since we are referring to the 7th and 8th data, or the smaller between these two, which is 19. So we add the result 0.5 from 19. So we have 19 plus 0.5 or 0.5 plus 19 is equal to 19.5. Therefore, using linear interpolation, our upper quartile value will be equal to 19.5. The second quantile is known as to be the decile. These are the 9 score points which divide a distribution into 10 equal parts. These are the 9 deciles which are denoted by d sub 1, d sub 2, d sub 3, and so on until we have d sub 9. In such organization of data, 10% falls below d sub 1, 20% falls below d sub 2, and so on, and 90% falls below d sub 9. So using this graphical representation, our d sub 1 or the first decile, we have 10% of the data is less than or equal to the d sub 1, and so on. Now, to compute for the deciles for ungrouped data, we will compute this the same way that the quartiles are calculated. So let's have an example. The scores of 12 students of grade 10 Bonifacio in a math quiz are 9, 10, 11, 13, 14, 15, 15, 16, 18, 19, 19, and 20. So it was mentioned that there are 12 scores, so our N is 12. The smaller value, or the smallest value rather, is 9. The largest value is 20. Our given data are already arranged in ascending order. Now this time, in finding the deciles for ungrouped data, for the position of that, we use now d sub k is equal to k over 10 times n plus 1, wherein our k refers to 1, 2, 3 until 9. And we'll be having over 10 because we are referring to the decile, meaning we divide our given distribution into 10 equal parts. Now let us find the d sub 3 or the third decile. So the first step is we arrange into ascending order, and the next is locate its position using the given formula. Our k now here is 3 because we are looking for the third decile. And then we round off to the nearest integer. Thus, position of d sub 3 is equal to 3 over 10. Again, this is over 10 because we are referring to the deciles. And then our n, we have 12 scores mentioned. So 12 plus 1 is 13. And then we have 3 over 10 times 13 is equal to 3.9. Rounding off to the nearest integer, we have fourth data. So among these numbers in an array, the fourth number or fourth data will be 13. So therefore, our d sub 3 or the third decile value is now equal to 13. Percentiles. These are the 99 score points which divide a distribution into 100 equal parts. These are 99 percentiles which are denoted by P sub 1, P sub 2, P sub 3, and so on till we have P sub 99. So they are used to characterize values according to the percentage below them. So in such organization of data, we have 1% falls below P sub 1, 2% falls below P sub 2, and so on, and 99% falls below P sub 99. So given this graphical representation, we have 25% of the data is equal or less than the 25th percentile, and so on. So the same manner in solving for the deciles and quartiles for ungrouped data, we can also compute for the percentiles of ungrouped data as the same way. So let's have example. The number of seconds 10 contestants answered a 15-second question in Math Quiz B are 6, 7, 8, 8, 8, 9, 9, 9, 10, 14. Now, the given are already arranged in ascending order. We now locate the position of the score in the distribution. Let's say we are looking for that 67th percentile or the P sub 67. We use now the formula P sub k. P refers to the percentile is equal to k over 100 because we are dealing with percentiles, meaning we divide the distribution into 100 equal parts, times the quantity of n plus 1, and then we round off to the nearest integer. Thus, the position of P sub 67 is equal to our k again is 67 over 100. Our n is equal to 10 because there are 10 contestants. So we have 10 plus 1 is equal to 11. And 67 over 100 times 11 is equal to 7.37. As we round off, we have the 7th data. So among these numbers in the array, the 7th data will be 9. Therefore, our 67th percentile or P sub 67 is equal to 9. Remember, the median is equal to Q sub 2, D sub 5, and P sub 50. Deciles and percentiles are related in the following manner. We have D sub 1 is also equal to the P sub 10, D sub 2 is equal to P sub 20, and so on, as we have D sub 9 is equal to P sub 90. And then quartiles and percentiles are related in the following manner. Our Q sub 1 is equal to P sub 25, Q sub 2 is equal to P sub 50, and our Q sub 3 is equal to P sub 75. As illustrated, given the line segments, for the given quantiles, we have the quartiles, percentiles, and the deciles. So the measures of position indicate the relative standing of a data value when data are sorted in numerical order from smallest to largest. The corresponding percent of data values are less than or equal to any measure of location. This means that lower percentiles, quartiles, and deciles always correspond to the lower data values. And high percentiles, quartiles, and deciles are always correspond to higher data values. Okay, let's try this. The ages of 9 people in a room are 18, 19, 21, 21, 18, 20, 17, 22, and 23. Find the following: the Q sub 1 or the lower quartile, D sub 5 or the 5th decile, P sub 75 or the 75th percentile. Let us check. For our Q sub 1 or the lower quartile, we have 18 or the third data from the given array, we have 18. And for the D sub 5, our 5th data will be our 5th decile, that is 20. And of course, for our P sub 75, our 8th data will be 22.